Welcome to myprojectbazaar.com.
Now we discuss about the product for a graph-based algorithm to minimize total wire length in VLSI channel routing. Next, we see the abstract for the product. The channel routing problem is an important step in the layout design of VLSI circuits. Channel routing with the minimum wire length reduce the cost of the circuit, delay of propagation signals, and give better electrical performance. However, channel routing problem of wire length minimization is NP hard. There are several channel routing algorithms that have been developed to minimize the different cost optimization of channel routing problem. A channel is a rectangular routing region that has two open ends, and the upper and lower sides of the channel has two set of fixed terminals. The two set of terminals are aligned to vertical and in the on bot in columns at the top and bottom of the channel, and their other ends of channel are open. Terminals are assigned to some other integer terminals with the same number of are to be electrically connected and are called net. A channel is usually specified by the netlist or channel specification. If a net contains only two terminals is called two terminal net. The net contains one or more than terminals called multi-terminal net. This span between the leftmost and rightmost columns of the net has been interval the net. Minimization of total wire length is one of the most important problem in layout problems in VLSI physical design. Minimization of wire length not only reduce the cost of physical wiring required, but also reduce the electrical hazards and having long wire in the interconnection, power consumption, and signal processing delay. Since the problem coupling the minimized wire length of the routing no debug and two-layer channel routing for NP card, it is interesting to develop the heuristic algorithm that compute the routing solution unto low total wire length as possible. In this paper, we develop the efficient heuristic algorithm and approach the reducing total wire length using the distance-based algorithm for overall place position for overall architecture. Next we see the flow diagram for the product. First, the source data are applied to our routing architecture process based on our routing selection using the heuristic algorithm. First, we define the distance based for each and router position for source to destination calculation, and all the path distance calculation based on our the distance based algorithm, and to calculate the distance and to distance calculation to minimize the path estimation. This minimized path estimation mainly based upon the our low count of distance calculation for overall architecture. Then the source to destination part, and to calculate the minimum level of distance in channel routing, and to allocate the router position for source to destination part. The source data to be allocated for destination, and to choose the source to destination, and to calculate the probability of path allocation in source to destination, and the calculation of probability to be calculated for the distance calculation based on our position requirement for each and every router connectivity, and to apply the connectivity, then to calculate the low minimum distance for source to destination part, and to identify the minimum path estimation, to calculate the synthesis and simulation report for overall architecture. These results then calculate the final output for our the source to destination data transfer using the distance based calculation for a graph based algorithm to minimize the total wire length of in channel VLSI routing methodology. Next, we see the final output for the product. First, we design the Xilinx IC project for router architecture designs. Then, to open the router designs, this designs was developed in VHDL language, and to develop the structural modeling process for overall architecture designs. Next, we select the simulation process, and to select the NOC design to run the simulate behavioral model. Then to open the ISM process level, then the process to be used to simulate our the overall forecast for NOC architecture designs based on the wire length minimization methodology. Then to open the ISM project navigator. Then apply the input bits and to activation for the clocking signal. Then to reset function to produce the output result for based on our distance based algorithm designs. This is our the distance based calculation result, and to identify the minimum distance result, then to pass the data to get the output data for required minimum distance path, then to run the clocking signal and to activate the reset function, then to store the address for any of the data, then to activate the writing conditions, then apply the input data for any of the input data, then to apply the clocking signal for our overall architecture process, then to deactivate the reset function given to the clocking signal, then to get the output data for source to destination passes, then the source to destination passes to calculate the minimum calculation for position based overall NOC architecture designs, and to find the lowest design, then to transfer these path to identify the source to destination data. This is our activation for the clocking signal based on our output data for overall NOC architecture designs. This is our the simulation process for overall architecture design. Then to go to the implementation process. The implementation process to select the NOC designs and to calculate view the RTL schematic diagram. This RTL diagram to generate the what are the logical paths presented in forecast for NOC architecture based on our distance calculations. This is our the NOC designs for design calculations process. Then to go to the technological diagram. The technology diagram which represents the what are the lookup tables and input output buffer elements, then to pass the overall architecture designs in our final output for NOC architecture. This is our lookup table and input connection wire connectivity for overall architecture design. Then to calculate the design summary process. Then design summary process to synthesis report for generation for device utilization result. This device utilization result to identify the area of overall NOC architecture designs. Then to calculate the design summary process. The design summary process to calculate the minimum period level and the clocking frequency. Then calculate the latency level for processing time for overall NOC architecture running process.